Hey guys, this is Mr. Pasco with another lesson on networks. This time we're doing Euler Trails and Euler Circuits as used for centuries by Texas cowboys following the Euler Trail down in Texas. Texas, I really love doing I was there. The landscape's a lot like Australia. You've got oil rigs owned by wealthy oil barons. You've got beef cows and great steaks. Sorry for the animal lover people. And you got cowboys as well. So there you go, Euler. That's how he pronounces his name, because he was Swiss. It's not Euler, even though Europe is Europe. He's not Euler, apparently. He's Euler, just like the Oilers down in Texas. Anyway, enough jokes about Euler's name. Euler Trails and Circuits, they're really important for household garbage trucks, believe it or not. And we'll find out why in this lesson. So this video will flow a lot better at higher speeds. I'm a slow talker. I'm not great at using those drawing pens. So make sure you use the video player tools cog on the player bar to increase the play speed. And what we mean by that is there's a tools cog on the player down in the bottom right hand corner. You click on that cog and then go to playback speed. Click on that arrow and make it 1.5, 1.75 or even 2 times speed. And then the video will flow a lot better and it won't be so long to watch. In our previous lesson we were learning about paths and trails and circuits and cycles, and a trail, we learned, was a journey that does not have to end at the same place it started, but you can only travel along each connector edge line once during that journey. Now, an Euler trail is just a special version of that trail. All right, so an Euler trail is just a special one where we must go along all the edge lines in the networks exactly once, okay? So we can't just go somewhere and stop. We've got to go to and visit all of these lines. We're going to travel along all the lines there, all the parts of the Euler Trail. So let's have a look at how that works. Now, a tip for making an Euler Trail is to make sure you start at a high degree vertex. So don't start at A that's only got like 2 connectors and is only degree 2 on its vertex, and don't start at D. Start at either B or C. So we're going to start at B because it's got 3 connectors here. So that's a tip when you're doing an Euler Trail. Try and start at a vertex that's got a high degree on it. So from B we can go up to A, and then we can go down to C, we can go up to D, down to B. So we're allowed to go to B twice, that's all right. We haven't gone along the same edges twice. And then to C. Okay, and then we're finished. So we don't have to get back to where we started when we're on a trail. We can start at B and end okay at C, 2 different places, that's fine. And you're allowed to go to vertices more than once. So you see, we started at B, and then later on we came back to B again from D. That's okay, as long as we went along every edge. And if we check that out, every edge of that network, we have traveled along it like a cowboy riding the trail. We've been along every edge line, but we only did it once. So that is an Euler trail. Now, there's other ones you can do as well. You could go B, C, D, B, A, C, or you can start at C, and you could do like CA to B to D to C to B, or CBA, CDB. So you can trace those out and try it. So as usual, there's several different answers often to these questions, and that's okay, as long as we go along all of those edge lines and we only go along them once, we have done an Euler trail. Okay, and good old Euler, we love Euler and his formulas because he's come up with a formula that tells us if an Euler trail can be drawn. Okay, for an Euler trail to exist, there has to be exactly 2 vertices in the network with odd numbered degree. There can't be less than 2, there can't be more than 2, there has to be exactly 2 that have an odd number like 1, 3, 5, 7, 9 as their degree, and we'll show you what we mean. Here's that network which we just did the Euler trail for. But if we were wondering first, I wonder if it's even worth trying to figure out an Euler trail for this, we can use Euler's formula, and we love Euler and his formulas. So A has 2 lines coming out of it, so its degree is 2. D's also only got 2 lines, so its degree 2. B has 3 connector lines coming out of it, so its degree 3. And C has 1, 2, 3 connector lines connecting it, so its degree 3. Okay, now when we check out those 4 vertices, we've got a 2, a 2, a 3, and a 3. All right, so A and D both have 2, so they're even degree, because remember the even numbers are 2, 4, 6, 8, 10, so they're both 2, so that's an even one. That's not helping us out because we need exactly 2 odd ones. But here it is all coming good because B and C are other 2 vertices. They're both odd numbers. They're both 3. So we do, in fact, out of those 4 vertices, we do have 2 of them which are odd numbers, okay? So for the 4 vertices, we've got exactly 2, B and C, that have odd numbers. They both happen to have 3. And as we saw previously, we can make an Euler trail. So we can sort of check degrees of vertices before we start on a network, especially if it's a big complicated one. We don't want to be sitting down there ages trying to draw trails if it's actually impossible. So get the degree on all the vertices and make sure you've got exactly 2 vertices that have odd numbers. If you've got 3 that have odd numbers, that's not going to be any good. You can't do an Euler trail. And if you have none of them have odd numbers, you won't be able to do an Euler trail either. You've got to have exactly 2 of those dots have Euler trails. Now, why are Euler trails so useful? Postman Pat loves them. He's given them a double thumbs up, and garbage men use them as well. So on an Euler trail, if we do this one, this is an Euler trail. We're going visiting all the dots. So we're going C to D to E to, C to D to E. Then we're shooting across to C, and then we're going to A, and then we're going up to B, and then we're coming down to E. So we have gone along every single edge in that network, so that is an Euler trail. And if these were houses that we had to visit, either delivering letters or picking up garbage bins on garbage day, this works perfectly because we've managed to visit all the houses, and we've only had to go up each of these kind of roads here or lines once. So that is the most efficient way to deliver letters or to collect garbage. And that's why Euler trails are fantastic for Postman Pat, double thumbs up from him, and for garbage workers. So if we check out on this Euler trail, A's got degree 2, B's got degree 2, D's got degree 2, C in the middle there has degree 3, and E also has degree 3. So what do you know? We have got exactly 2 vertices with odd numbers. We've got C and E, and that's why it was possible to do an Euler trail on that network, okay? And that was what was drawn out. So 2 odd vertices, and the rest even like that is perfect. We can draw an Euler trail, and that's perfect for Postman Pat and for garbage men. So there we go. That is why Euler trails are so useful. Now, most of us aren't going to be postmen or garbage truck drivers, but you never know. And Euler trails will be useful. All right, some questions from the exercise. So we're going to jump into question 7 in exercise 5.4. So if 2 of the vertices are odd, then we'll be right. We should be able to make an Euler trail. So we have to identify whether we can make an Euler trail or not on this graph. So we need to check out all the vertices. So let's start at A. A has this curvy one, and a straight line here and a straight line here. So A's got 3 connector lines coming out of it, so it's degree 3. B down the bottom left-hand corner is also degree 3. C is, that's not a 1/4, there's 1, 2, 3, that's a connector line. There's 4 connector lines, because you've got that curvy one as well. There's 1, 2, 3, plus the curvy one makes 4, so it's degree 4. D also has 4 lines connecting to it, so it's 4. And E has 2. So when we look at all those vertices, all 5 of them, we've got a 2, a 3, a 4, a 4, and a 3. So we do have 2 odd numbered ones, and exactly 2 odd numbered ones, because all the rest are even. So we should be able to make an Euler trail for that particular network. And in part B of this question, they ask you to actually make the Euler trail. Let's have a look at number B now in question 7. So here we've got a network, and we need to trace out, and sorry, we've got the exact same network there. We're doing part B, we're actually going to do the Euler trail. So an Euler trail should be possible. So we're starting at A, and the first thing we're going to do is we're going to go from A round to C, trying to make our Euler trail. Then we're going to go up to D. Then we're going across to A. Then we go down to B, because we're trying to go along every line, every connector line in this network. And so then we can go up to D. And so what we're doing is we've been kind of around the outside, and now we're doing the inside zigzag. So now we're going from D to E. So those Z shapes in the middle, we're now working on them. We're going from E across to C, and C back to B. So that's kind of our complete Euler trail, where we've been along every single connector line in the network, even the curvy one between A and C. So the tip was to go to a high degree vertex. So we wanted to start, we wanted to head from A, because we were starting at A. The first place we wanted to head was a really high degree vertex like C, which has 4 lines coming out of it, okay? We wouldn't connect, or we could have gone to D first because it's got 4 lines coming out of it, all right? So you want to head straight to one of those high connector vertices and then try and get round the outside first. So we were concentrating with these purple lines, if you notice they're purple, sort of getting round the outside first. And then after we'd done that, we couldn't actually go to C, I don't think, to work this out. But after we sort of got round the outside, then we concentrated on this kind of Z-shaped things in the middle, the crisscross ones in the middle. So we went up to D, zigzagged over to E like a slalom skier down to C, and then back to B. So we're kind of doing zigzag Z shapes. So that's a tip. Head for a high degree vertex, try and get around the outside of the shape, and then do the inside zigzags like a slalom skier. Okay, so that was the sort of the tip for doing that one. And that might be useful for other shapes you do as well. Okay, so 7A, this is part 3, so we're not going to do all of them, we'll leave some for you to do. This one here, we're trying to identify first if it has an Euler trail, so we need to check out the degree of all of those vertices. C has a degree of 5, there's actually 5 lines coming out of that, or arced curves, 5 things altogether. F down here only has a degree of 1, 2, 3, it's got 3, so it's got odd, and that's exactly 2 odd, so we're looking good. But when we get to vertex G, that has degree 1. It's got 1 connector, and 1 is an odd number. So this shape here actually has 3 odd vertices. The rest are all even if you check them out, like A's 1, 2, 3, 4. H is another odd one actually up here, so there's 4 odd ones. But here's where we sort of broke the bank anyway by getting an odd one here, because remember, we're only allowed to have 2 odd ones to be able to do an Euler trail. So we've got 3 already showing, and there's another one up here with H, so we've got 4. So it's definitely not going to be an Euler trail. So if only 2 of the vertices are odd, we're good to go. But we've got 3, and there's actually another one hiding up there with H that we didn't see. So there's actually 4. So no way, all bets are off. You had to have only 2, and we've got 3 showing and another one up here that we can turn over playing our card game and make 4. So no Euler trail for 3. So that's good. We don't have to do a part B and draw the Euler trail, so that's a bonus. Right, so let's get on to question 5 here. In 5A, we're identifying an Euler trail. Okay, so remember our tips. Head for a high vertex kind of point. So E has 1, 2, 3, 4 coming out of it. Don't head to F that only has 2, or A's got 3, but E's better because it's got 4. Don't go to C first up because it's only got 2, all right? So head for a high degree vertex, and we're going to try go around the outside first and then do the inside zigzag, because you can see there is sort of an outside shape, and then there's this sort of crisscross Z for Zorro shape in the middle. So that's kind of our strategy for this one. Now, this strategy doesn't always work, but it does work a lot of the time. Okay, so we're going to start at B and go straight across to E, and then we're going to go up to D. So we headed from B, where we were starting, straight across to the high degree one, E, that had 4 lines coming out of it. Then we're trying to get round the outside, so we go B to D, then D over to B, then we go round to A, then we go to F, and then we go up to E. And we've nearly done all of the edges, okay? We just now do the zigzag ones in the middle last. So from E, we shoot across to C. That's a zigzag one, a Z shape, and we go down to A, and then I think we've done them all. That's it. So our answer is BED, if you write that down as you go, BED, BAFE, then we went to C, then we went down to A, and then that's it. Now the book did a different one. They started at A and they went AFE, so they kind of went along the bottom here, got along to E, which was the high degree one, and then they worked from there. But both answers are okay. So there's other answers as well. So remember, there's often more than one answer for it. And up here we had an Euler joke. This guy's trying to change the oil, but he's got no idea what he's doing. So he's saying, yep, that's the engine. Okay, so he probably needs some help from his dad, I'd say. All right, Euler Trails. This is number B, and I'm assuming this is 5B because we just did 5A. So tip, start at a high degree vertex. Then do the horizontal. Oh, this sort of doesn't really have a round the outside one. So we can't use our round the outside strategy here, but we do have kind of Zs that go horizontally, like here's a big Z for Zorro here. And then there's these up and down Zs. So we're going to start at C, the high degree vertex one. So we'll go straight to that. It's got 3 coming out of it, so that's a good one to start at. And we're going to do the horizontal zigzag first. So we'll start at C, and first up we'll go across to E, then we'll go across to B, then we'll go across to F. So see how we've made a Z? We're doing the horizontal kind of zigzags. Then we'll go to G. Now we'll work on these vertical zigzags, all right? The ones that go straight up and straight down. So we're working on them second, and you can finish it off and write out the full vertex letters journey. Okay, this answer will be different to the actual one in the back of the book, but it is a valid answer. Remember, there's often more than one answers to it. So we've sort of started at a high degree vertex. That was our strategy. We did the horizontal zigzags. Now you just need to do the vertical ones. I think if you do them, it's going to turn out pretty good and won't be too hard for you. Okay, in the Euler graph, if an Euler trail commences, so they're telling us here we have to start at A, and we've got to work out if we follow an Euler trail, what vertex are we going to finish at? Okay, so we have to start at A. So our strategy in this one is to get rid of this A to C loop, because see how there's 2 ways of getting to C? So do this little loop first. So we have to start at A, so we're starting at A. It says that in the question, commences at vertex A. So read the question carefully. Get rid of this little loop first, then go around the outside, because this has got sort of an outside we can go around, and then do any internal stuff, any zigzags that are in the middle, okay? Do that last. So let's give that a go. We go from A across to C, and then we come back to A again. Now, you could have done this the other way too. You could have gone from A to C and then back along the straight line to A. As long as we do that little loop there and get that out of the way first. Now we're going to start going around the outside. So we go A to D, D to E. Now that jumped in too early because I think we're going to make you finish this off. Yes, you can finish the question off. So we've started this going around the outside. You have to do A, D, D, E. Then you'll have to go H, F, B, C, and then at the end you'll sort of be doing the C and this other one here, sort of the inside ones, okay? And then you should be able to find what letter this guy finishes at, and you should find that it has to end at E. There's no other way to do it except ending at E, even if you don't follow our tips and try to draw it another way. All right, so we'll leave you to finish that one off and write out the full letters journey. The answer should come out as E. All right, so there you go. So the Euler trail, now remember, because it's an Euler trail, we have to go along every line. So you can say, oh, Passy's already done it and he stopped at E here, so we're finished. That'd be okay for a normal trail, but for an Euler trail, we've got to make sure we went along every single line here in the network, and we haven't done that yet, so you have to finish it off. Lesson 5b, Euler trail is needed for computers using, our good old friend, the adjacency matrix. Okay, so in question 9, they ask you to construct adjacency matrices for the graphs you had back in question 7, and then use the adjacency matrix to check out Euler's rule and see whether it's possible to draw a trail or not. So let's go through this. So in question 7, okay, we had the actual graph picture, and that was fine. We were able to look at it and work out A had 3 sticks coming out of it, so it was degree 3. D had 1, 2, 3, 4, so it was degree 4. So we're able to check out all the degrees on the letters and work out that we had 2 odd ones and we could draw an Euler trail. So that was all really good because it was just us just looking at it, which was fine. But remember our friend the dumb computer from previous lessons. The dumb computer doesn't have eyes, and the dumb computer cannot look at a network diagram or graph and process it. The dumb computer needs one of these adjacency matrices where we translate all the connections that are happening in here into a matrix. And computers are really good at doing matrices, although they call them arrays, but they're the same thing. And then they can work it out, all right? So how do we get this guy into an adjacency matrix? We've done this in our previous lessons. And remember A here, A, if we're looking at what A connects to, so does A have one of those round circle loops? No, it doesn't, so it's a 0 in here. This is A connecting to B, this one here. Now, if we look at A, it does connect to B, so it connects to B once, so we write a 1 in here. A connecting to C. A has this loopy thing that goes around and connects to C, and it only does it once, so that's got a connection. And A going directly to D. Yes, there is this line here that goes straight from A to D. So we've got a 1 there. Now, does A go directly to E? E's over here. The boy's face hit it, I think. Hid it from view. That's the E there. Now, A doesn't go directly to E. There's no direct path. But people might get confused and go, yes, you can get to E. You go to A to D and then over to E. But remember, we need to go not via another vertex. We just need to have a straight line connector, so there's only 2 dots, and that would be 3 dots if we did that journey. So there is no direct connector from A to E, so that's a 0 in there. So the degree of A, we can look at it and go, oh yeah, it's 1, 2, 3, but the dumb computer can't. But the dumb computer can add up the adjacency matrix and go, oh, okay, there's 1 plus 1 plus 1 here. The degree of A must be 3, and that's an odd number, okay? So the computer can add up going across here for all of the connections. The next connections for B show B here and what B is connected to. B is connected to D, it's connected to A, and it's connected to C. So notice there's a 1 in A, C, and D because it's only got 1 connected to each of those, all right? And then it doesn't connect to itself, and it doesn't connect to E. If we look at B, E's up here where the little boy's face hit it. He's hiding it from view, but there is no direct connection from B to E, so that's a 0. So if we add them up, we've got 1 plus 1 plus 1, 3. We've got 2 odds. Well, that's looking good because remember we need exactly 2 odds for a Euler trail to be drawn. Now, when you check out C, it's got 1, 2, 3, 4 when you work out the adjacency matrix and add up going across. So that's even. This has got 1, 2, 3, 4 when we add them up. That's an even, and E's the one out here on its own, and it only connects up to D, and it only connects up to C. So it's only got 1 plus 1 is 2. Okay, so they're all evens, and yes, we do have exactly 2 odds. So there is an Euler trail for this network, and we actually drew it, I think, back in the other question. All right, so remember the dumb computer cannot look at a network graph or diagram, so we have to put the graph into an adjacency matrix. Then the computer's really good at working with matrices, and it could add up these horizontal rows, work out all the degrees, find out that there's 2 odd ones, exactly 2 odd ones, and then the computer could say, yes, an Euler trail can be drawn for that, okay? So that's why we have to use adjacency matrices. It's all because of dumb computers. And we need computers, though. They're not dumb. They're useful for really big networks and processing them. All right, so lesson 5b. Now we're looking at Euler circuits. So not electrical circuits, although it's a similar idea because the electrical current flows round and round the circuit. And that's the idea of the circuit, that we're going around it. Now, on an Euler circuit, you have to make sure you use up every single edge. So it's like an Euler trail. We've got to go along every edge, but we have to get back to exactly where we started, all right? So let's start at A in the middle. So it's a good idea to start at a high degree vertex. A is the biggest one here. It's got 5 lines. No, 1, 2, 3, 4, 5, 6 lines coming out of it. So A is the one to start at, just like we did with trails. Start at the high degree vertex. It's got lots of sticks connected to it. And travel along each of these triangles. So you can see basically there's a triangle over here, a triangle over here, and a triangle over here. So if we just do the triangles one at a time, coming back to the middle point A all the time to start the next one, well, then we should be right. So here we go. We go A, B, then we go from B to C and C back to A. So we've done that first triangle, done all the edges in that. Now we'll do the one on the right. We head over to D, down to G, and back to our home base at A there. And we've done that triangle. And now we just have to do the bottom triangle. So we shoot down to F, across to E, and back to home base at A. So we started at A, and we've ended at A, and we've done every single line edge connector in that network. And so that is an Euler cycle. So it's the same as a trail. You've got to use up all the edges in there, but you have to start and finish at the same place like we did. We started at our home base here in the middle at A. All right, so the Euler circuit there is A, B, C, A, D, G, A, F, E, A, when you write out the letters of all those things we traveled along. Okay, so that's how you'll see it written out in the book, and that's the way you need to write it out. But you do this kind of drawing on the diagram to figure it out, okay? But that's how you write the answer. All right, so our Other things, circuits use a different, now there's an Euler rule for circuits as well. We love Euler and his formulas. He's always got a formula for everything. He had one for the trail. Now the one for the trail was that we needed exactly 2 odd vertices, but he's got one for his Euler circuit as well. So he's such a good guy, because we're going to find later in this chapter some other things don't have formulas, but Euler's a good guy. He always gives us a formula, but it's a different one for the circuit, okay? For the circuit, all the vertices have to be even degree. You cannot have any odd ones. So forget about having 2 odd ones. If you've got 2 odd ones, it's bad. You can't do a circuit. You can do an Euler trail, but you cannot do a circuit. To be able to do a circuit, all the vertices have to be even. Now, if we check out that one we just did, the 3 triangles, A was in the middle and had degree 6. B's got degree 2, so we'll just go in alphabetical order. C's got 2 connector sticks, so it's a 2. D's got 2 edge lines coming into it, so it's a 2. E has got 2 connector lines, 2 edges there, so it's degree 2. F is degree 2, and G is degree 2. And if you look at all those numbers, 2s and 6s, they're all even numbers, okay? So every vertex has an even degree, so we can make an Euler circuit for this. And we just prove that by drawing the Euler circuit. You cannot do an Euler trail. You can't do something starting and finishing at a different place and using all the edges because we don't have 2 odd ones. But we do have all even, so we can do the Euler circuit, and we just did it before, so that's all good. So just remember, it's a different rule for the circuit to the trail, and don't get them mixed up. All right, so an Euler circuit, every edge is used once. Here's just another drawing, which I think was taken off a website or out of a book. A circuit should exist if all the vertices are even degree. Now, the difference between the trail and the circuit is the trail does not have to start and end at the same vertex, but the circuit does. So when we do the circuit, you've got to go round and use all the edges and begin and end at the same place. When you do the trail, you've got to go round and use all the edges, but you end at a different place. Okay, an Euler circuit, every edge is used once. So this is the circuits when we go around and start at A here. You can see we started at A, we've been around the circuit and finished at A. So that network there does have an Euler circuit. And the reason it has one, if you check out the degree, B has 2 connectors, A has 1, 2, 3, 4 connectors. And if we go around there, A, B, C has 1, 2, 3, 4. So all of them have an even degree, okay? And that's why it's possible to draw this Euler path. The 1 means that's where you go first. So you go A to E first, then 2, that means you go E to C, then you go from C back to A, then you go from A to B. So you follow these numbers, B to C, then C to F, F to E, and E up to D, and D finally back to A. So there's 9 edge lines on there you've got to go along, and these numbers tell you the order you have to do them in, and that's how you write out your answer. And you can write out your answer without hyphens and put all the numbers together if you want to, right next to each other without the dashes, that's okay as well. And how we can check first, before we went to all that trouble of trying to draw the circuit, the idea is to check your diagram first and just make sure all the degrees are even. If they're not all even numbers, forget about struggling doing all of this, because you'll never do it. You need to have all even degree vertices to be able to do an Euler circuit. So that's a tip for doing questions. So question 6 here, it says identify an Euler circuit. So start at the high degree vertex B. Now let's just check it out. C's got 1, 2, 3, 4, D's got 2, E's got 2, F's got 2 connectors, G's got 4, H has got 2, A's got 4. Yes, so everything does have an even number for its degree, so we should be able to draw the Euler circuit. We're not wasting our time here. And the question says identify an Euler circuit, so we kind of figure it is possible to do it. Now we're going to start at B and end at B. So we're going to use our old strategy, starting at the high degree vertex. B has 1, 2, 3, 4 things coming out of it, so it's a good thing to start at. Don't go starting at I with only 2. A might have been okay to start at because it's got 4 things coming out of it as well. But we decided to start at B here and use our old strategy of first going around the outside here and then look at going in the inside, all right? So let's try that out. So for the first bit, going around the outside, we've just drawn it in. So we started at B and we went to C and we just went all the way around here with the letters until we got back to B. And now we just have to do the inside. So to do the inside, we just went across to J, then up here, down here, round there in the purple until we got to B. So the purple one's the inside track. We went from B to J first and followed the inside track around. We initially started just going around the very outside. So we started off at B, we did this pinkish track first going up to C, all the way around getting to B. Then we went across to J and did the purple track, okay? And every edge has been coloured in, so we know we've completed the circuit. Now you just need to finish this off and write out those actual letters in order. So write B, C, D, E, B, C, D, E, G, A, I, etc., etc. Now, our answer is different to the book's answer. Remember, there's often more than one answer to these questions, all right? So if you want to look at the book's question, try and trace that out and prove it's a circuit, that is fine. Now, you need to do exercise 5.4, page 216 to 217. If you're in my class, other people might have just been watching this to learn about trails and circuits, and that's fine, and they can do whatever questions their teacher has for them. But only do the Euler questions. Some of these 5 and 6 have Hamiltonian questions, which we're going to do in the next video. So don't do the Hamiltonian ones yet, just do the Euler ones. And we've done quite a few of them in the video and given you tips on how to do them, all right? And one more little joke about Euler. Euler's other rule. We've got 2 rules in this lesson, that if you've got exactly two odd degrees, when you check out the vertices, you can do an Euler trail. If you want to do an Euler circuit, though, and go all the way around and use all the edges, you've got to have every degree of a vertex has to be an even number. Euler's other rule is that doing Euler work is not easy. Expect your Euler work to be challenging. Now, I still reckon it should be Euler, because we say Europe and we don't say Europe. So I'm wondering, because he's Swiss and his name's Euler, does that mean if I went to Switzerland and asked the Swiss people to say Europe, they'd say Europe? I don't know. Anyway, it can be challenging enough just to pronounce Mr. Euler, whatever his name is, properly. So do those questions, and we will see you in the next lesson.